and I'm very honored to give a talk on behalf of the team. So this research was done together with Tisa University. So the title of the talk is called Digital Payment Fraud Detection Methods in Digital Ages in Industry 4.0. That's been published in Computers and Electrical Engineering, a Q1 journal article with the link here. So I'm going to give outline as follow together with overview, background, workflow, methods, results, and conclusion. And as we know, we move into Industry 4.0. It allows so many organizations, including the financial organizations, to adapt the processes and mitigate the risks and losses associated with fraud. However, the number of roles has always been on increasing level. This makes the fraud detection very tricky due to many factors, such as the money and customer spending behaviors, and also the number of transactions and complexity also have increased. Machine learning has presented promising solutions to tackle the above problems. Why we can optimize the customer database with real-time transaction details so that we can double check whether it's genuine and whether it's the real person, and we can automatically detect frauds and verification method if we have improved our algorithms further. So our research objective is to identify an efficient and stable model for fraud detection platforms to be adapted for Industry 4.0, so that it allows everybody to have pay and use any financial services in a very safe manner. We can evaluate the ability to detect fraudulent patterns of different models, ranging from supervised to unsupervised learning. And that includes the 4 of the supervised algorithm. In this case, they include the logistic regression, KNN, that stands for K nearest neighbor, decision tree, random forest, and then unsupervised algorithm, which stand for autoencoder, in this case, to compare with the performance and find the best model. And our contribution that includes, first, we present the practical learning algorithm to generate the predictive fraud models adapted for financial business in Industry 4.0. Second, we handle feature selection issues to reduce redundant and irrelevant features from actual data sets. You know that the data set may not be in a perfect shape, therefore we have to reduce redundant, irrelevant feature. But also the next thing is the imbalanced data, and we provide the solution to tackle the imbalanced data by doing the oversampling, ensure that is called smoke, and undersampling, ensure that's called near miss techniques. And we're going to get into a little bit detail later. And we use the real transaction data set to analyze the performance of several learning algorithms to recognize fraudulent patterns. So in a way, they can understand how fraudulent patterns behave. So that is our contribution. And the background, the Industry 4.0 then draws a new industrial strategy by integrating the organization with comprehensive technology related to connectivity, digitalization, and automation. As a result, the business works steadily to rely on data, and with increasing hacking and unauthorized access, information systems have become more vulnerable. Therefore, the fraud detection is a prominent part of cybersecurity in Industry 4.0's era. So we are very fortunate to have the data from a European credit card holder transaction that's available on Kaggle in September 2013. So in summary, we have more than 284,000 transactions, of which 492 were fraud. So this proportion is on an increasing basis, but in this case, if each case is a fraud, they may result in loss of financial losses. And then, as data scientists, we have to have a general understanding about data. So we then get a 30 feature that include time, amount, and so on. They stand with different variables. So due to the confidentiality issue, features V1 to V28 are principal components obtained with PCA. So not all the information can be widely available. But in this case, we then can run an overview of a data set just to see how it looks like. The feature distribution of the feature name on the x-axis and the density on the y-axis, the red color, that represented by the fraudulent transaction. As you can see, the fraudulent transaction may happen in those cases which can be closely aligned with a real transaction or can be very different with a transaction. Therefore, it makes us to have an urgent need to understand the patterns and how the fraudulent transaction happen and what kind of behaviors that tend to lead us to think this way. So as we know, when we're running advanced algorithms, we should have a very structured way of working. So first of all, we have a data set and we then pre-process the data so to ensure that the quality is much better. And then we then can explore data and sampling data. In this way, we then use 80% to train our data and 20% to test our data. And then with the machine learning models, we then use supervised and supervised learning. Then the next step is that we use the evaluation metrics. There are other ways to use. Then we have chosen AUROC and precision. We will explain briefly a little bit later, and then we then compare with different experiments and results so that we then have outcomes. And in this case, we run several machine learning models and to then compare the results. And in summary, you may ask, how can we detect a fraudulent transaction? So it is a tough question. It's been for a long time. In our proposal, we then have those steps. First, we use the supervised learning. Then second, with the unsupervised learning. Then we then have the feature extraction. For instance, a principal component analysis such as PCA. And then with the oversampling and undersampling to ensure that we don't miss anything. But that is very important because we do not know which part may have the incurring fraud or in which case that fraud can be happening. Therefore, we have to use a comprehensive ways to analyze the data. So supervised learning, that includes the logistic regression, which means that you then run the regression just to see anything wrong and any outliers and so on. And k-nearest neighbor classifier also try to do the same thing. If let's say the normal transaction work their way and you will find some outliers or some kind of patterns. They are quite distant from the normal way of transaction. And then decision tree then will also help us to calculate the probabilities and also identify in what cases and what percentages it can get to the frauds. And random forest will also let us decide, like if in the algorithm and that decides that which majority is the best, then we'll go for it. And then autoencoder is unsupervised learning because sometimes frauds may just be done by independent hackers, just to do any random thing. So therefore, we also have to use unsupervised learning and to have a better understanding, and feature extraction will help us just to see whether can we just extract something very insightful and crucial, or just to check do we miss anything. And oversampling and undersampling will be also essential, just in case that we can also do more overfitting and then underfitting, and then also to have special analysis by paying more attention with different approaches. So it allows us to have a very comprehensive way for conducting data science and data analysis. And the methods, just in a short summary, a logistic regression that stands for the prediction transform using a logistic function returns the probability value between 0 and 1. So it has been widely adapted for Industry 4.0 because it's easy to implement, it has a good accuracy, and it's very efficient to train. And k-nearest neighbor can based on similarity measures and group based on similar manner. So when certain things that behave certain way, they then group them together. So there's no need for any training. for model generation, its accuracy does not impact even new data agent, therefore is suitable for real-time fraudulent detection. And also decision tree, as you can see, this is just example. You then can get into true or false, and then you then have a probability followed by this. So if true, it goes to that. If false, it goes to that. And then you have different outcomes following your choice. So you can also have a branch just to have a analysis on the decision node. And the decision tree is one of the most widely used algorithm, and where the data is continuously divided based on a specific rule, such as if then else decision rules. And also it's easy to interpret, it's fast, and there's no need for much effort in data preprocessing, like scaling data, and easy to overfit and solve. Random forests become the decision tree's weaknesses. Combine predictions from multiple trees to make more accurate prediction than a single one. So first of all, you have more trees, and secondly, it will help us to decide, because the algorithm also if it goes for the majority, then the decision tree, a particular tree may be the one to take over. And random forest can be also combined with decision tree. And autoencoder is a kind of unsupervised learning. So it's a neural network architecture whose output is the same size as input, and used for anomaly detection to check anything that goes wrong. As you can see, the inputs will get compressed further to a bottleneck, and bottleneck is the one to reconstruct the input. Therefore, the output is a kind of reconstructed input in a way that to check anything goes wrong. Imagine if, let's say, you go to the airport for checkup, and then the officer just asks you to take up everything on your luggage, and then after that you put them in a nice and reconstructed way and put them back, and to make it more organized. And then that's the research question we have to think about: the best approach, detect frauds. In this case, we propose having 5 experiments, and in that will allow us to have a very comprehensive method. We are not going to lose anything. So experiment 1, to have a baseline experiment. Experiment 2, to adjust the algorithm with the class weight to handle imbalanced data, so that in some cases, the imbalanced data will not lead to more outliers or some unexpected results, or may just lower accuracy. Experiment 3, we undersample. Experiment 4, we oversample. Experiment 5, we use the unsupervised algorithm with a different batch sizes and also learning rates. Then we are going to just present the result. So in our paper, we do explain the background theories and also the meanings. But in this case, we have the accuracy, the AURC, average precision, sensitivity, specificity with the original features and PCA. So then we are running 2 separate competitive sets of data, and with the experiment that stand for logistic, regression, k-nearest means, decision tree, and random forest. Then we run our results. Then we use the formulas. Please read our paper, then you will understand more details. Okay, the accuracy. They are very high. They are always 0.98 and above. AURC, that's also high by ranges between 0.9 and 0.971. And the average precision that has more variation that between 0.824 to 0.921.7, and sensitivity that's in an average of 0.83 to 0.86, and specificity very close to 1. But then when we begin to adjust class weight, one obvious thing you notice is that the specificity is not always 1. It will sometimes get to 0.98 for some of them. But however, sensitivity goes up, because when you get rid of imbalanced data in the way the sensitivity is higher on average, the average positions in this case is also slightly higher compared to the previous experiment, but then in some cases can be lower. So AUROC is also having very closely matched results, but in some cases you may have a higher ones, or in a few cases slightly lower. And accuracy now is changed between 0.97 to 0.99. And for the experiment 3 and 4, the experiment 3 is a near miss undersampling, and experiment 4 is small oversampling. So in this case, that you notice that there's no too many changes for accuracy. And AUROC, as you can see, there's some slight differences. The most obvious differences, the decision tree slightly lower, but then however most of the results are very comparable. Then with the average positions, it has a slightly decline, but then the most obvious ones, the decision tree, and then compared to the result here is slightly less. So it may mean oversampling, probably sometimes doing too much. You know, sometimes we have to do it better by doing less, but sometimes we have to do a bit more, but then we do not know which one is a better approach. But in this case, the sensitivity are slightly higher than the result in experiment 3. And then the specificity, here you have more ones, but here you have more 0.9998 and so on. So now let's talk about the result in general. They also include experiment 5, which I will explain this. So the result shows that, first of all, accuracy is very high. We always get 96% above. Sensitivity is 81% because it varies, because in some cases that you may get lower, and in some cases we get higher. And specificity, we always maintain high, and that is a very good sign. So in most cases, the AUC values are 0.9 and above, which means that we have a very good quality, and most of the data are pretty consistent. And effects of undersampling and oversampling, that depends on algorithm, because the different algorithm will give you a different outcome. So we noticed that if we use random forest, and also we use a PCA, and with the undersampling strategy, we achieve the highest AUC value. In this case, we want to use AUC as a kind of a measurement to test our quality. Then we have a value of 0.976, which is considered high. And at the same time, the decision tree and oversampling, the performance is not so good. So we can also make a comparison. We can put all the result analysis and then compare the outcomes, and you can then see how each of the model that looks like. So in this case, that the random forests are always staying very high, and you can also see that the logistic regression is not that bad, but in some cases the fourth experiment not so good. And then you can see that the decision tree was sort of okay, but then it falls very low in experiment 4, and then in the KNN doesn't normally perform that well, but it was also quite acceptable. At least you stay 0.9 above. Then with the average position, and that's another type of experiment, we determine whether there's a fraud or a good detection of that. And we notice that there is a very high, there is a consistency for both logistic regression and random forest. The results are very high, and especially towards the end, random forest seems to get a slightly better outputs. And then with the decision trees, it varies very extensively when, especially towards experiment 5, and then with the KNN, it doesn't seem to perform that well, but then it was sort of still acceptable as long as it gives the values of 0.8 and above. And also we have the autoencoder is only maintaining above 0.8 for experiment 5. And we then can talk a little bit on experiment 5. And this is the result. We then use the autoencoder Then we have the batch sizes approach, learning rates, fraud class, MSE, normal class, MSE, auto row, average precision, accuracy, sensitivity, and specificity. While doing machine learning algorithm, we got to be able to do very thorough tests. We have to go through all the detail. We have to check that everything that works. And for detail, please read our paper. Okay, we will kindly appreciate it. So autoencoder has consistently achieved good performance with an accuracy of 96% through different batch sizes and learning rates. So in a way, we then ensure that it always maintain a very high rate of 0.96 and above. Then we then can potentially apply unsupervised learning as a data labeling, could take time and resources. If we do not have the issue for resources, then we then may consider either to use it for thorough tests, or perhaps we use an alternative solution. So let us just look at this reconstruct error for different classes. As you can see, if it's normal, in most of the time, the data points are staying here, but occasionally it may go up. It might be because you are paying a large amount of money in a short time, or it might be because your paying or buying behavior are very different from normal. For instance, that let's say you after COVID, you go to somewhere for shopping, and the first time you try to buy everything, you tend to be more generous because you have been probably kept at home for a long time. But then you may notice that fraud, they have something very consistent. There is always very bizarre behavior, very unexplainable patterns. So that's why if it's obviously outliers, then we can detect there is something is not right. And we have to set a threshold in a stricter way, because although we may accept there are certain data points, although they are the normal transactions, but above the acceptable level. But then if the threshold is not set high enough, not set low enough, we can only accept a very, very small percentage of error. Then we may not be able to catch some of the unusual behaviors, because for fraudulent data and fraudulent payment, you can catch some signs that shows that certain things are not right. And if they say the financial institution feel that there's something not doing well or not going well, then we are not going to accept that as a satisfactory transaction. So the conclusion is that we compare different machine learning algorithms to find the best model to detect fraudulent transactions, and the random forest is the best performance model across the performance metrics, followed by logistic regression. They are both very close, as you have seen in the previous figures. And the integrating undersampling approach achieve better performance when handling school data than oversampling and adjusting class weights. So in this data set, it's just that if we want to dig in further, the data sampling seems to be more reliable to give you a kind of a better performance, and then oversampling. But then in some cases, it may not be the same. So by then in our research, we realize that the undersampling approach may be more suitable for fraud detection. So why should you cite these papers? First of all, the intelligent approaches have been successfully utilized in our research, and therefore our work can be adapted to recognize fraudulent activities automatically for Industry 4.0. Second, we identify the effective model for detecting frauds in digital payment. That's a very important thing now, because with the AI-enabled security, will allows us to detect the frauds even in real time, and hyperparameter automation for supervised learning algorithms, because we have a very sophisticated algorithms to ensure that things are robust. And solution, we have a solution to imbalance problems in data and suitable feature selection, because there's no such thing called perfection in data. We have to realize that we have to accept a certain extent of imperfectness, but not too much, because when it's having too much, then it may have affect the quality of analysis later on. And also it might have a problem with the biasness in the results and analysis. So lastly, we propose the appropriate performance matrices for imbalanced data, such as AUC, precision instead of accuracy, because accuracy may not be the best representation when you have some external imbalanced data, which is quite common in some of those challenging fields, and also in the areas that the data set may not be always highly consistent. And the references are here. So if you can, please go to our paper and please consider citation, because we need your support, and your support and encouragement will give us everything we need. We kindly appreciate this, and thank you so much for everything, and we wish you all the best. And if you can also consider subscribing to our channel, because these days doing applied research is not easy, and your support gives us all the motivation and all the hopes we have. Thank you. Have a good time. Bye.